Welcome to Easy Electronics videos. In this video, we are going to talk about node voltage method. I am Fatima from the Easy department of the University of Utah. Basically, node voltage method helps us to find any node voltage in a circuit. And it is just a combination of KCL and the node voltage concept which we covered in the previous video. So let's suggest a system for node voltage method to make it a little bit simpler. So first step is to use KCL as always, but it would be much more convenient if you have the currents measured out of nodes and kind of pointing outwards, which means the summation of I's is equal to 0. The second one, you're going to use node voltage and Ohm's law and substitute currents in step 1 with voltages and resistances. In step 3, never pass the next node. So let's show this with an example. In this circuit, we want to find what is V1 and V2 by using node voltage method. So the first step is to apply KCL. All the currents are measured going outside, so the summation of measured currents are equal to 0 for the V1 node. The same thing happened for the V2 node. So the second step is to use node voltage and Ohm's law to substitute the currents in the previous equations with voltages and resistances. Okay, let's find out what is I11 here. So it seems this is a little bit of a tricky node because you have a power supply there. If you actually apply a KVL in the top loop, it will be minus I11 multiple 2K and 10K ohm resistance minus 5 volts plus the node voltage at V1 equal to 0. That gives us I11 is equal to V1 minus 5 volts minus 0 divided by the summation of all the resistances in that loop. So if you don't want to apply KVL, you can also consider the top right node is basically V1 minus 5 volts. So you can just write I11 is just V1 minus 5 volts divided by the summation of all the resistors there, which is 10 plus 2K. For I12, if we use node voltage, it's basically just V1, which is our initial voltage, minus 0, or the reference, divided by all the resistances that we have in that branch. It is the same for I13, so we have V1 minus V2 divided by 18K. Remember, we are not passing the second node, so we are not passing from V2 and we stay there. This is for V1 node. We substitute the currents in the KCL equation with their equivalents that we calculated just now. And all of them should be equal to 0. This is the equation for V1 node. Okay, now let's find the currents in the second node, V2. So I21 in here is just V2 minus V1 divided by 18K ohm. I22 is again the initial node voltage V2 minus the second node voltage, which in here is reference and it is 0 divided by the resistance in the branch, which is 10K. And I23 is just V2 minus 5 volts, since there is a power supply there, divided by the summation of all the resistors there, 3 plus 12K. So we have two equations, two unknowns, and we want to solve what is V1 and what is V2. By calculation, and you can just do this in MATLAB, V1 is equal to 1.6 and V2 is equal to minus 1.1. Okay, so now let's measure these two node voltages in the circuit and see if really they match with the calculated ones. This is the schematic and this is the actual board that we built. Okay, now let's do the measurements. We have two 5 volts power supply that we are providing it with these USB phone chargers. There are extra resistors at the two sides to make sure that there is enough current drawn out of the power supplies that they stay on. So now we want to measure V1 the node voltage V1 and the node voltage V2 to make sure that our calculations were right. And we get 1.6. Very good. So far, so good. So far, the theory does match with the measurement. And now let's measure V2 over here. Minus 1.1. Perfect. Measured V1 is 1.6 volt and measured V2 is minus 1.1 volts. This shows that node voltage method can help us to find node voltages at any point in any circuit. Thank you for your attention.